Hi, geometry students. Mrs. Suoja here. Today, I'm going to do section 4.1 notes with Cami. Right now in Canvas, this set of notes is posted only as a PDF. So you can open it up, and if you want to print it out and just follow along with pencil paper, that's totally fine. If you want to just follow along digital with Cami, you need to open your document with Cami. So the way that you do that is you need to upload this PDF document into your Google Drive, and then it should look like this. Once you have it opened inside your Google Drive, you should be able to open with, and I have the Cami Chrome extension. If you don't have the Cami Chrome extension, you need to go to the Chrome Web Store and search that out and then load it up so that you can also open it with Cami. All right, let's continue on with 4.1 notes for geometry. Today we talk about the triangle, the mighty triangle. All right, so first thing is to talk about the interior angles and the exterior angles of a triangle. So I'm going to grab my text box here and just say the interior angles are just the three angles inside the triangle. Angle. Okay, sorry, I paused so I could make the printing just a little bit bigger. All right, an exterior angle, it has to be created, and that is an angle outside the triangle. It gets created by extending one side of. All right, so angle D is the exterior angle. And you can see that this line side of the triangle was extended to create that angle outside the triangle. A, B, and C are the three interior angles. And just one observation is that angle A and angle D are supplementary. All right, we can't introduce triangles without going over these vocabulary words. My guess is you guys have done these more than once in your math history, but we'll just review. Triangles are divided into or classified by two things: the lengths of their sides and the sizes of their angles. So the three vocabulary words that go with side lengths are scalene, isosceles, and equilateral. So a scalene triangle has 0 congruent sides. All right, an isosceles triangle has 2 congruent sides, at least 2 congruent sides. I mean, basically, we are going to always just think of them as having 2 congruent sides. And an equilateral triangle has 3 congruent sides. All right, so the tick marks on these triangles, hopefully you recognize the tick marks. Double tick marks all the way around marks all 3 sides as being the same length. Okay, classifying triangles by their angles. An acute triangle has 3 acute angles. A right triangle has 1 right angle. Can you see why it can't have 2 right angles? Okay, an obtuse triangle has 1 obtuse angle. All right, so that would be that angle right up there. Can you guys see why it can't have 2 obtuse angles, right? We couldn't really make a triangle out of it with 2 obtuse angles. And an equiangular triangle has 3 congruent and acute angles. And we haven't talked about it yet, but we actually know exactly how big each one of those angles is going to be. So that will come up maybe after we do the triangle sum theorem. If I can hone my video editing skills in a very marginal way, then hopefully next you're going to see a justification for the triangle sum theorem. All right. So if you just watched the video, what we figured out is that when you add the three interior angles of a triangle together, they add up to 180 degrees. That means the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. That little tidbit of information is going to be something we come back to for the rest of the school year. So 180 degrees interior angles. Remember that. Okay, and now we come to this theorem about the exterior angle of a triangle. So angle 1 is shown as an exterior angle right now, and it is, we know it's supplementary to the angle that it's right next to, but this theorem talks about its relationship to angles A and B. And let's see if I can mark this up. Angles A and B are two non-adjacent interior angles. So non-adjacent means that they don't share a vertex or any sides. So you can see between angle 1 with A and B, right? They definitely don't share a vertex or they don't really share sides from that vertex. And A and B are the interior angles, whereas angle 1 is the exterior angle. So our theorem says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. It's a long sentence, but it's a pretty simple theorem. Okay, sorry, I got interrupted there. So where was I? Measure of angle 1 is equal to the sum of the measures of the two non-adjacent interior angles. So angle 1 is equal to measure of angle A plus the measure of angle B. And that is all we are going to do to solve these two equations down below here. All right, so we know that this angle, the 3x minus 9 angle, is the exterior angle, 3x minus 9 equals, and it's going to equal the sum of the two non-adjacent interior angles. So 73 and x. 73 plus. Okay. Now we'll just subtract x to the other side. 2x minus 9 equals 73. Then we will add 9 to the other side. 2x equals 73, 83, 82. And then divide both sides by 2. Okay. Let's see. So we are supposed to actually do a little more than just find x, right? We're supposed to find the measure of angle DBC, DCB. All right. I'm just going to pause for a sec and see if I can find out use my equation editor to get that angle DCB up there. Okay, so I grabbed that equation editor so I could write angle DCB. And then I kind of finished with the equation editor, which is a little awkward in CAMI. So if you're using CAMI and you want to move your equations around, you have to hover and then go grab the white plus. So angle DCB should be 114 degrees. All right, and then the interior angle that should go right beside it should be the supplement to 114. So I would take 180 minus 114 and get 66 degrees. Okay, so that's the angle right inside there. And then I'm just going to do a quick check really quick to see if my math is right. So I'm going to add 66 degrees plus 73 degrees plus, I got 41 for x. And I just want to kind of verify that my angles really do add back up to 180. So I would do 66 plus 73 plus 41. And I just punch it in my calculator to be fast and both lazy. It does equal 180 degrees. All right, so I know that my math actually checks out. All righty. Now we'll just kind of move on to number 2. I just can't decide. I kind of just almost prefer doing the text box, honestly. So I'm going to go back to my text box. All right, so we are going to say 3x plus 16 is going to equal the sum of the interior of the non-adjacent interior angles. So that's 52 plus 2x. And I will just put myself on pause while I solve that, so you don't have to suffer and wait for me to go through all that. Okay, so I got 36 for x. Angle DCB is going to be 3 times 36 plus 16. All right, and once I get that answer, I can find the measure of angle 1 by finding the supplement to what angle DCB is. Okay, so measure of angle DCB is 124 degrees. And then the measure of angle 1 would be the supplement to 124. So 180 minus 124, which equals, I got to put in a new box there, 56. Okay, now I won't do it on paper because I'm just kind of like out of space here. All right, 56 degrees for angle 1, but I'm going to do a little mental check. I'm mental checking it with my calculator, but I know that the 56 degree angle plus the 52 degree angle plus the 2x angle, which would be 2 times 36, they should all equal 180, and they do. All right, thank you. That's it.